So next we'll take a look at combinations of putting these transformations all together, combinations of transformations. So now this is a lot, so let's not worry about writing this down. This just has everything put in here all together. So we have the vertical, that's the up and down. We have the horizontal, left and right. We have the reflections here, and we have the A out front, the vertical distortions. And they just use B in here, but that's that K value we've been talking about. So really that's a K we've been looking at. Okay, this is everything at once, but we're just talking about, again, the point of this is just to see, again, we're going to go through it using the points. We're not just going to do random sketching. We're going to be given some coordinates, and we're just going to essentially relabel those coordinates with a different value. That's how we're going to be able to check things. Okay, don't worry about copying this down. You have this already down. This is just everything all sort of at once. So this is where this has all four things together here. So we have this vertical shift on the outside. If it's positive, it's up. If it's negative, it's down. We have the horizontal shift in here. If it's negative, it's right, and if it's positive, it's left. We have this horizontal stretch and compress. We multiply the x values by 1 over k. And we have the vertical stretch and compress. We multiply the y values by the a. And that includes the negative as well, that reflection. So how are we going to tackle all these? We're going to execute these manipulations essentially from left to right, like we read a book. Now, a special note here, if there's a horizontal translation, the coefficient of x must be factored. So all that means is that, if we have a quadratic, if we have 4x minus 8, we have to factor inside the bracket the 4x minus 8. We want to rewrite it as, because there's a common factor, right, between 4. If I said, have a common factor between 4 and 8, you obviously know it would be 4. So I would pull that common factor out front and just rewrite it as, 4 times x, 4x, 4 times negative 2 is negative 8. So you want to have things written in factored form. That allows us to figure out the proper k value and then the proper left-right movement. Okay, if we left it, so in reality, our k would be 4. So I'm going to multiply my x values by 1 over 4, and I'm going to have this horizontal movement of right 2. I'm just going to slide right 2. If I didn't do the factoring, I would move everything right 8. It would be wrong. So we have some of these simple graphs. The quadratic, a couple others. The square root function is easy. Linear, straight lines are easy. But we'll have some of these functions, and we'll have some of the specific functions as well. So how do we organize all this? What's the best way to do it? I think the best way for us is going to be a table, because it's going to be tricky to figure all these things out at once. So suppose I'm asked to sketch. Let's just start here. So y equals 2x squared plus 3. So here's my basic quadratic here, and I have some of these basic points memorized, 0, 0, 1, 1, and 2, 4. I know that. Here's what I'm being asked to sketch. A couple transformations here. I have this 3 and I have this 2. This is just everything all at once, just to help me kind of work through it. So I think what we're going to do is we're going to write down some specific points. So we're going to use for a quadratic 0, 0, 1, 1, and 2, 4. And then we're just going to write down A, K, D, and C in order here. A, K, D, and C. And I'm just going to move my way left to right through this and try to keep track of what's happening on the points. So we're going to start with A. The very first thing here, this number out front, this A, this number out front. That means I multiply my y values by A, which is 2. So I take a look, and my y values get multiplied by 2. So my x value stays the same. Okay, the 0 stays 0. In this case, it stays the same as well, but 0 times 2 is 0. Okay, 1 times 2 is 2, and 4 times 2 is 8. Okay, the x values stay the same, it's just the y values that switch. And that's my A. Now you're probably wondering, well, how come that's not a k that's attached to the x? Why is that a k? It's a good question. But because the squaring is only attached to the x, it's kind of like there's a bracket in there. It has to be looked at that way, okay? Because the squaring is just attached to the x and not the 2. So that's the function x squared. Here's the a sitting out front of my function. Okay, so there is no k in this case. There's no other number tucked in there, so k I'm not worried about. and there is no plus minus with the x, so the d I'm not worried about. And that's important to see. It's not like, we do have 4 manipulations going on here. We don't have to have all 4 manipulations occurring at the same time. We maybe only have a couple at a time. So it's okay for us, we're going to skip through the middle 2 and just get down to the last one. So this plus 3 just means add 3 to the y values. Excuse me. So my y values here, 0, 0 becomes 0, 3. 1, 2 becomes 1, 5, and 2, 8 becomes 2, 11. So I just added 3 to the y values. If I were to sketch that, I go over here to 0, 3. I'd have 1, 5, and 2, 11. It's kind of off my page there, but it would look like that, and it would take off like that, the new graph. Okay, so something a little more challenging, the square root function. So I'm being asked to sketch this square root function. Here's the basic square root function. I do say memorize it, but you're not going to memorize square roots. They're easy, right? So in this case, I have my x value is 2. The square root of 2 is 1.4. Don't worry about memorizing that one. But, for example, 4. The square root of 4 is 2. So that goes there. Here we have the square root of 9 is 3, which is there. The square root of 16 is 4, which is there. The square root of 1 is 1, which is sitting down there. So you can just memorize the integer square roots. You know them anyway, but that's the basic function, and we'll put an arrow on there because it does continue. Here's all 4 manipulations, allow us to go through it. Here's my table. I picked off some points here. I'm going to do 0, 0, 1, 1, and 4, 2. These are easy points. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. So they're easy points to use. And again, I'm going to go A, K, D, and C, just left or right, like I read a book. Now I'm going to factor this. I want to point this out because I have 2x minus 4. I have to write that in factored form. So I common factor the 2 out front. I have 2 bracket x minus 2. That gives me my proper horizontal movement. So here we go. So the first thing, there is no A. There's no numbers sitting out front here. So I don't worry about A. I skip it. There is a K because this is within the function. So this K, you see how here's my function, f of x, and there's my K tucked within the function. Here's my function, my square root occurring. My 2 is tucked within it. So if my 2 was out here, that would be an A. But my 2 is inside the function, so we treat it as a K. So I multiply my x values by 1 over 2. So my x values, 0 times a half is 0, 1 times a half is a half, 4 times a half is 2. My y values stay the same. My d, okay, I do have a horizontal movement here. I'm going to add 2 to the x values because it's negative 2, so it goes right 2. So I add 2 to the x's. So 0 plus 2 is 2. 0.5 plus 2 is 2.5. It's okay to have decimals, that's fine. And 2 plus 2 is 4. And then my last one, I have a plus 3, so I add 3 to the y values. 0 plus 3 is 3, 1 plus 3 is 4, and 2 plus 3 is 5. If I were to sketch this, 2, 3, I would be here, 2, 3, 2.5, and 4 is there, and 4, 5 is there. So it looks like, something like that, kind of a rough sketch, but that's how I'll be able to track these things with the values there. Okay, and try these, page 129. And again, there's a lot of transformations here, and you're probably saying to yourself, how come I don't just put all these things in Desmos and graph it and get it perfect every time? And that's a good question, and I sort of agree with you on that. So we're not going to get too carried away with these transformations. If they seem kind of confusing, just practice them as best you can, work on them as best you can, use Desmos to get through it for sure. Just as long as you get a sense of what's happening with these transformations, that's okay. We're not gonna bury ourselves in these. We're not gonna have really convoluted, complicated functions with a whole pile of transformations that we have to sketch out and do by hand. We don't have to worry about that. Okay. Anything too complicated, anything that's really difficult, we're just going to use software to graph. So now we're really just trying to get a sense for some simple transformations and just fundamentally how they work. Okay? Okay, good luck.